What's up, guys? Let's continue talking about set node. So last class, I noticed some of y'all were coming up with some creative ways of making placing a lot of nodes with one place, right? So you place it and then boom, a bunch of stuff would happen. So I wanted to kind of work on that a little bit more, expound on that. Where we actually builds a house, a very primitive and simple house, when you place the block. And as you can see here, this is part of what it will do. This is two different instances of me placing it, one here, and each time I placed it, I wrote the code so that it would put wood all to the side of it. So I'm going to show you how to do that in your code, and then I want you to take that and adjust it so that it builds a box. And if you really want to put a cherry on the cake, add a roof to your house. As you're going through this, I do want you to focus on actually just finishing the task, right? Just get the task done. But there's a lot of other problems that I'll just mention at the outset of this. As you place and then you make a box, it will be full of just whatever was there, right? A tree or whatnot. You have to go in and you have to clear it. So you might want to think through how you can actually clear out the inside of your house. And that is in the chapter that we are talking about. That we are covering. It's in that chapter. And so if you want to go and look at that, that'd be great. Anyway, so that's one of the problems. The other thing that I think would be cool is if it found rock, then rock or dirt, it wouldn't build into that, maybe. Or maybe dirt it builds into, but rock it doesn't. And then it just kind of... And that would be fairly simple. Again, it's in the same chapter. And I might... anyways, just a couple ideas as we're proceeding. Okay, so here's our code. We have on construct. As soon as that block is placed, it will execute this code. And as you probably remember, XYZ is the position of that block. That's very important. We can use that position to then locate the placements of all the other blocks in the world, right? And we use that by adding to Y or X or Z, or subtracting from X or Y or Z. And we set the nodes by using Minetest.set, giving the location and then giving the name. Now what we want to do is we want to place a whole bunch of blocks, right? One after another. And so you could... The simplest but hardest method would be to change, it like this, and in which case it will just add a block up and up and up. Of course, you're going to end up with a huge amount of instructions carrying on for quite a while. If you're talking about like a 10 by 10 wall, which I built in my last one, that's 100 lines of code. And so that is just not what we want to do. There is another way to do this, and that is with something called for loops. If you remember, we covered for loops way back in the Lua days, and let me take you on over to a page. This I found by Googling Lua for loop, and then it looks like a tutorials point is a great place to find Lua instructions. And so here we have just a simple syntax, kind of general overview right here, kind of explains what it does in words. But then this is kind of nice right here. I don't know if I can somehow... Okay, so just as a slight refresher, we have the code coming in here, and there's some sort of... I don't know what initialize exactly means. That's the number, or the variable that's going to contain the iterations. And then we have a condition. Now, is that number, has that number reached 10? No, it has not. So what it does is, okay, so then if that is true, if that code is under 10, then it goes to the code block, and then it adds 1 to that variable, comes up to the top and tests the variable again, and says, is that variable less than 10? Yes. Continues, is that variable less than 10? Yes. Is that variable less than 10? Yes. Until finally, is that variable less than 10? Is that variable less than 10? No. Condition is false. It then continues on. So that is how a for loop works. And here is the code. This is an example, and I love examples because it kind of cuts to the chase. I can see it a little bit better, the usage. So I'm going to copy that and then head over to Notepad++, and I'm going to paste it in here because if you're tracking, then you'll realize this is a great way to simplify the lines of code that you have to write. It does the same thing over and over and over, however many times that you tell it to. In this case, for this example, you'll notice that when the above code is built and executed, it produces the following results: 10, 9, 8, 7, 6. So it actually goes from greatest to least, and that makes sense because you see the conditions here. I is going to start at 10, and it's going to go to 1, and it's going to increment by -1. So it's going to step down from 10 by 1. So 10, 9, 8, 7. Now, what I would rather have is it go from 1 to 10. And then, of course, you can't get there by going backwards. You just never will. We got to increment it by 1 up, right? So that'll be 1 to 10. And we're going to have the variable, the container that's going to hold the value, be I. All right, so that would be good for simply creating, and we'll just do that. This would be good for creating like a row of a certain material. And I'm going to comment out, or you can delete that line that we had before and paste it down here, because inside this for loop, we're going to be setting the nodes. All right, and so instead of, and we could just leave it as y. So y, instead of saying +1, which is a static variable, it's a static number, we want that number to change so that each time this code is run, it's adding not just 1, but 2, but 3, but 4, and so on, right? So we do that by saying I, because I contains the value up here, right? 1 through 10. Fantastic. So now what we do is we save that, and we go over to Minetest, and now I got to exit. All right, now we're getting back in, and now if I go down to somewhere, you'll see, if I could just, boom, on top of it, 10 pieces of wood have been placed. Well, that's all fine and dandy, but unfortunately that's just straight up, right? We want a wall. So how do we do that? Well, if you get really creative with this and you think for just a second, you might realize something. What you could put a for loop inside of a for loop. What would happen if you did that? Let me first type it out and maybe you'll be able to get it. Okay, so here we have the extra for loop. Instead of using I use J. And so what happens is when this one starts, it says it sets I to 1, right? And once, so I is set to 1, and then it comes down here, and then it then sets J to 1. But this for loop has to complete. J has to get from 1 to 10. And so I stays at 1, while J, this for loop goes around and around and around, and J goes from 1 to 10. Then once it leaves this J for loop, it goes back down to end and up here again where I becomes 2. I becomes 2, and then it comes down and repeats the whole process. Where I is 2, J will increment from 1 to 10. So you can think of this like placing rows of blocks. I are your rows, and then J are your columns. And you know what might make it a lot easier to see this is by using R and C, so rows and columns. Now, instead of putting so what I need to do is I need to put Minetest inside of the second for loop, or else it's not gonna. This second for loop's really not going to be of any use to us. So we put it inside the second for loop, and and now it depends. Like when we're talking about rows, we could do a row in an X direction. We could do a row in a Z direction. So I'm just going to do it in the X direction plus R. And then Y we're going to say is of course our height. And so that would have to be, I'm sorry, no, Y would be our rows. X would be our columns. And so now let's see what happens. Remember to exit and then enter back into your code. Oh, and also don't forget to save your Notepad++. But there you go. It adds a whole wall of wood. Very fast, by the way. And but you know, there's some minor tweaking that we could do. So why is it placing it up here and not down here on the ground? And why is it not like taking up this spot? Which maybe we don't want that. I don't know. Yeah. So there's just a couple things that need to be ironed out. But that is how you make one wall. And I don't really care. It can be up like that. You don't have to solve that issue. All I really want is a cube. And so just create a cube in the world. Everything that you need, I've given to you. Everything that you need. So using that nested for loop, you should be able to create the rest of the walls. So this right here is one wall. What you would want to do is you don't put more for loops inside of these for loops. You don't. I'm sure there's a way of doing that, and if you can figure it out, great. All more power to you. But what I would do is I would come below that and then add another nested for loop, like so. I'm sorry, I thought I copied that. Like so. You can use R and C again, but then change up the variables for a new wall and figure out how to get that wall to place going the other direction and so on and so forth. So that's what I want you to do. Just a little more fun with set node, and then next week we are going to get on to ABMs. Thanks for watching, guys.